All right, so for our first problem, we had to input 10 integers, and then if there were any duplicates, we had to store distinct integers into a new array. So we have our for loop where we start inputting these numbers, we see in our number, and then we go down here to this if statement. So if this is true, so if it is distinct, we go down here and we see that it will search through our array. And if the number that was just input equals anything in the array, then it will return false. So this block will not execute, so that number will not be stored in the new array. But if it doesn't equal anything after it searches through the whole array, it will return true. This will execute. And then we display our array. And actually, because the array is still the same number, it will display some garbage. Hopefully, you will get to see exactly what numbers it deleted, sort of. Didn't delete them exactly. That cell, that section of the array is still there. And because there's nothing in it now, it will display some random number. But you'll be able to see that it actually worked that way. All right, so for our second problem, let's see, we had to generate some values between 0 and 9 and then figure out how many of each value 0, 1, 2, 3, etc. there were after doing this 100 times. So he had int math.random. I believe that works better for Java, though I couldn't get it to work here. So what I did is I used rand, but if you use srand, you can seed it with something, time as an example, and just set the time. And so that way it will actually give you different answers each time you use this program. So initially I set the array, all of the values to 0, just in case. You never know. It's possible that you never got a 9 or never got a 0 or something. So if that's the case, it will display that. Otherwise, we go through and do our values 100 times. And so for each time, our variable j is equal to our random number, and then our counter, our array, will go to that index. So say we got a 5 as a random number, and the count will go to that index and add 1. So it was 0, now it is 1, and it will do that for every number. And so whenever we see out down here, the number of this index will be, and we'll have a tally because it's added it up each time. Then we need to free up our space, of course, because we did another dynamically allocated array, and that about gets it for that one. This one I probably made way too complicated, but it works nonetheless. I had some practice code already written. It was easier to copy and use that. I probably could have done everything in one fell swoop instead of how I did. I swapped, or I sorted the array and then swapped everything else along with it. So took a little extra time. Definitely want to optimize this if I was doing it again, had a little more time. So we're going to see on the number of students. We wanted to know how many there were. We want to know their test scores. All right, so how many students and scores will you enter? And then the user will input that. If it's less than 0, we'll say, whoa, hey, can't be negative people. That doesn't really work. Try again. And then we have our test scores array, and we have our student names array. All right, so we have our for loop, enter the name for student, and just for sake of the user end, front end, it's I+1, so it will say enter the name for student 1 or student 2, 3, etc. And then it will read that in and have it at index 0 or I, and then also have you enter the test score at the same time, so that way the score and the student are tied together. We'll also use the same indexes for the test score pointer, again, so we know what score belongs to what person. And then again, some more validation. If the test score is less than 0, like, hey, you can't give a kid negative points on something. Then we're going to sort, is how I did this. So because the scores are integers, it's very easy to sort them. So I have basically a bubble sort, and we set swap equal to false, do our for loop. If A is greater than B, we'll store A, set A equal to B, and then set B equal to our stored value. Alongside that, if we had to swap right there, here's what I added in for this particular problem. So we also added in a temporary value for the name, and the name of A will get swapped to B, and B will get swapped to A. So that way it stays tied to the score. Now we're back in main. Students and names and scores in decreasing order are, and because they were sorted, I actually got to this and realized I had sorted them in ascending, rather than having to go back and figure out how to flip everything. It's actually very easy. Instead of starting at 0, we just start at the last index and go down. So students -1, j is greater than or equal to 0, j minus minus. So then we will see the student's name, say Derek or Sahej, and then we will see their score. And then again, deleting our memory, or freeing up memory. So this problem was a little intimidating when I first read it, but it said, as we see here, there are many possible solutions, but we just have to write one. So just write a program that displays one such solution, thankfully. To write an algorithm for this would definitely take some time. We need to validate whether there's only one queen in each row, column, and diagonal. So that would be quite the challenge. I'll work on that later. But simply for one solution, one way you can do this is just the use of a 2D array. I used a character array, and then just used ASCII code. 81 is capital Q, 32 is a space. And so we have stored this 8 by 8, which is the size of a chessboard, put queens in various places that fit this problem, the 8 queens puzzle. And then we're going to output this result. So we need our row tally and then our column tally. So for row 0, it will go to this loop and loop through each value. And then similar to the prompt, I have the bar, and then it would put a capital Q, and then a bar, and then a bar, and then a space, and then bar, space for that row. We've gotten to 8 in that row, so it will loop. We'll get to this end statement. We have another bar to make sure there's one at the end, and then it will go to the next row and start printing here. So we'll come back to the loop and we'll be on this row. And so it will do that for all of this. And so you could, if you change the code, you could input every way possible you want to do. All you'd have to do is come in and change where the Q's and the spaces are. So that would be one way to accomplish this. The other way would be to actually write an algorithm that would validate where the Q's need to go, the queens, I mean. So that does it for this homework. Thank you.